Hi, so we're going to explain how to implement our own stack. So, well, maybe the first thing that you want to ask is why bother to implement our own stack when Python has a perfectly good stack that we can already use? Well, the simple answer is Python's stack, it has to be implemented by somebody. And as a beginning programmer learning how to write code, it's important that we can implement our own stack. The more practical answer is that when at some point in our lives we're going to have to face solve some problem, and we're going to have to choose the right data structure to solve the problem. Now, in order to pick the right data structure, we have to understand how the data structures works. So, and there's nothing like understanding like implementing something to understand how it actually works. And then there are also times that, well, maybe an existing data structure wouldn't even do the job for us, and therefore we have to implement our own. So again, that leads to that we have to learn to implement some data structures, and stack is actually one of the simpler one that we can do. So we'll start with that. So what do we need to implement our own stack? Well, first we need something that we can store multiple items in a stack. So for that, we'll use the Python list. Now, we're not going to use all the fancy feature of a list, which, as we know, we can even use it as a stack, right? So we are going to use it strictly as just an array. And if you remember, array has a fixed size. So that means we're not going to use any operation on a list that can change the size of the list, such as append or delete, things like that. We'll only use the bracket, square bracket notation to access an item in a particular index. Okay, and then we'll also enforce that all the items in the list has to be the same type, just like an array. It's not necessary, but this is closer to what many other languages, the way many other languages would use an array. Okay, and the second thing is, so we'll use an index to access item, right? So the most useful index in a stack is kind of where the top of the stack is, right? So we'll have an index, top of the stack. It will be initialized to 0, and now let's take a look at how the index is going to change when we do push and pop operations. So in a push, let's say, so we start with an empty stack, top of the stack is 0, and we're trying to push 56. Well, where does 56 go? Well, it should go to where top of the stack is pointing to, right? The very first slot in an array. So we put it at 0, and then we should then increment top of the stack to 1. This is so that when we push another item onto the stack, such as 12, we don't put it back, we don't override it where 56 already is, right? We'll put it at the next available slot. So that's where we're going to put it, 12 at the top index 1, and then we're going to increment top of stack to 2, so that the next item being pushed will be put into index 2, right? So on and so forth. So kind of as a summary, then what happens in the push is the new item is put at the index that is pointed to by top of stack, and top of stack itself is incremented by 1. Okay, next, the pop operation. So when we do pop, you notice that we cannot really just return the item at top of stack because, well, there's nothing there. So what we should do is first we decrement top of stack by 1, and then we return what top of the stack is pointing to after it's decremented by 1, right? Which is at this point is 12. Another thing to note is that we don't actually necessarily have to physically remove the number 12 from the stack, as long as we decrement the top of stack properly, because when we want to pop the next one, we would actually, again, just decrement top of stack by 1. Now it's pointing to 0, and we will return what the item at index 0, which is 56. So in summary, when we do a pop, top of the stack is decremented by 1, and the new item is then taken out from the index top of stack. All right, so top of stack, if you can't see it by now, that it's actually a very, very useful attribute. So another piece of information that it can give us is that it can tell us how many items there are on the stack. And if you don't believe me, kind of go through the example and see that that is indeed the case. All right, so there are some other things that we want to include in the implementation. And one thing is, like we said at the beginning, that we want our stack to have to be using a fixed size array. So we want to know, how many, what is the maximum item we can put into that array, right? So we'll have a capacity attribute that remembers that number. And then another thing is we want to have this default item thing. And the purpose of that is twofold. So first of all is that we want all the items that we're pushing onto the stack to be the same type as the default item. Okay, and then the second thing is when we allocate a fixed size array, let's say of capacity 10, we want to fill that array with 10 of these default items. So another thing, the last thing before we start the implementation is that what kind of error are we going to run into, but in particular for push and pop. So if you want, pause the video, think about it for a moment. So in a pop, what might happen is that we've reached the maximum capacity, right? And how do we know that? Well, if you go back to the example and kind of, maybe draw, think through it a little more carefully, that happens when the top of stack is the same as capacity. Okay, that is when we fill up the stack already. And then another item in the push that can happen in the push is that the new item that is being pushed is of a different type from the type of the default item. Okay, now for pop, the problem with pop is, what if the stack is empty? There's nothing that we can pop off the stack, right? So, and it should be hopefully obvious that that we can check that condition when the top of the stack is actually 0. That's when the stack is empty. All right, so finally, we're ready to look at some code, which I already typed out. Let me try to explain that. Now, so the first thing we see in the myStack class is some constants. So we define a maximum capacity. We don't allow the capacity to go beyond this point. It's a little artificial, but doesn't hurt to have it. Second thing is kind of the default capacity, so which is used in the initializer. So we allow the client code to request how many items that a stack can store. Okay, so if we look at the initializer, obviously we will have the default items, and then we'll have the capacity. We have a default parameter value for capacity, which would be 10, and then we want to verify the capacity, right? Make sure it's not bigger than the max capacity, and that is with the validate capacity. Oops, there's a typo here. Anyway, and then now and if the capacity is invalid, we raise an exception, right, saying it's bad. Otherwise, we just kind of remember the two parameters, default item and capacity, and then we do a clear. Now, what the clear does is we kind of allocate the array that would be storing all the items, and we do this by using kind of a list comprehension that we build a list. Each item is in the list is just default item, right? And we also initialize the top of stack to be 0. Okay, and because we start empty, right? There's nothing in the stack yet. Now we put this code in a clear method rather than just as part of the init method. is so that somebody can actually just call clear to kind of reset everything, throw everything out in the stack and start from an empty stack. Next, we come to the two important operations of a stack, push and pop. So push takes an item to push, the new item, and we check for the two errors first. That we want to make sure if it is full, then we say, hey, it's full, we can do another push. And then we also check the type of item to push, make sure it is the same as the default item. And if it's not, then we also tell the caller something's wrong. Okay, and then we basically do what we said we were going to do. We put the item where top of the stack is, and we increment top of stack. In a pop, first thing we do is we check if it's empty, right? If it's empty, then we indicate an error. Otherwise, we decrement the top of the stack and return the item at the top of the stack. Okay, so now notice I used the helper method here, so to make the code more readable. And readability is something I'm going to repeatedly stress. It's very, very important to make your code readable. Another thing I want to just emphasize here is to report an error, I raise exceptions. So raising the exception is that means the client code cannot ignore this error, right? Because we really wanted to know when the stack is full and we're no longer allowing any push onto the stack. That is in contrast to returning an error where if the client code does not check the return value, then it would happily think that it has pushed something onto the stack even when it's full. Also, another reason to use to raise exception to report error is in case of pop. Now, if we don't raise an exception here, but instead if we return some special value to say the stack is empty, let's say we return the special value is we return none to say we don't have anything in the stack. Well, what if none is a valid item that the client code has pushed onto the stack? In that case, the client code really doesn't know that the stack, none means the stack is empty, right? So it's always good to raise exception to report error rather than returning something to report error. So that's what we're going to be doing throughout this class. So lastly, this is the rest of the code. These are the two helper functions. So is empty is when the top of the stack is 0, and the stack is full when the top of the stack is the same as the capacity. And finally, we have a getter for retrieving the capacity. All right, so now that we have an implementation, the next step is to test, and we have to make sure that we test our implementation very, very thoroughly. So that in this particular case of a stack, that involves, well, first we need to be able to instantiate some stacks, right? And remember, when we instantiate stacks, we can request a valid capacity, right, 10 or 100, or we can actually request an invalid capacity such as -1 million or something like that, right? So we have to test to make sure our code behaved properly in both cases. And then we should also test things like, we want to make sure, the getter for the capacity is returning what we requested. And then we have to do obviously a bunch of pushes to push both valid and invalid items. Again, make sure that it handles both properly. And then we also, if the capacity is 10, we will try to push 11 things in there and make sure the check for full capacity is working properly. And also, obviously, we need to check the pop operation. And then when we pop something, we have to verify that, if we just push a 1, then when we pop, we get back a 1, right? If we push 1 and 2, then we get back 2 and then 1. right? So, the pop operation return things in the right order. And then we also have to make sure that if we pop an empty stack, that is also tested. And so that is kind of in the test code here. I'm not going to go through it line by line. You should look through it and make sure, it does what I just said that it should do. And now, so for now, we go and what we have been doing is we manually test our code. That means, we write some test and then we kind of visually inspect the output to make sure they're right. So that is fine. But hopefully later in this class, we'll learn to actually write some better and automated tests.